Hello guys, welcome back to the channel, and this is the video about the linked list, and I have created a playlist called linked list here, and you can find all the problems related to the linked list, and I have uploaded it today only, and the next video coming up is like I will be covering all these topics, and each video will consist of 5 topics. So we will start with linked list insertion, deletion, deleting a given key, deleting at a given position, and the length of a linked list. So I will be creating 5 different programs for this, and you can check out my repository at any time. So, and these will be the videos for the following, and I will try to cover most of the problems here, and like in the um, difficulty at each video will increase. So these are basically 4 videos coming up for linked list, and maybe if I found some another problems also, I will be adding these, so this list might change. So every video will contain a the list of problems that I'm covering, so you will know by that video what problems I have covered. So let's start. So the first is linked list insertion, and let's just name it to linked list, and these are all the problems I will be covering. So yep, this is linked list, and now let's talk about insertion. So let's talk about the basic linked list first. I have given you a brief introduction about the linked list in this video, what is linked list, but I have not coded it. So let's code it. So this is our class which is known as simply linked list, and what you can do here is that you can create a void static class node here, and you can create an inner class that might be static or not. Let's keep that to static, and now you have a class node which represent a node of a linked list, and what it contains an element, so that can be an integer and the next pointer. Now you are just creating the constructor here, and this is the keyword that is used to reference to the current uh, instance of the element, and e. So yep, and next is equals to null. So now it's the basic structure of the node I have created. Now let's just create a static node head which will be equals to null initially, and now um, there is a static void main class. What I can do here is that let's refer to that head and add a new node here which has like one. Let's create the linked list like 1 is to 2 is to 3 is to 4. Yep, and that will next point to null. So head equals to new node, and head dot next equals to new node 2. So what I have got here is 1, what I have got here is 2, which are initially pointing to null, obviously, because it is mentioned that next pointer is null in the constructor. So head dot next equals to new node 3, and this is 1, 2, 3, and null. So head dot next equals to new node 4. So we just basically keep the pointer to the head node, as it is the mainly entry point for our linked list. You can not just write dot next and just keep a temporary pointer here, but to reduce the memory cost, I have just used only one pointer called head, and use .next. So basically when in problem solving you can use a temporary pointer, and as I have already mentioned that for all the solving of the problems of linked list, you just have to be good at like dealing with the pointers. So let's just make another function which is uh, print linked list, and let's just call that function so that let us know what is our linked list containing. So while head is not equal to null, and this system.out.print head dot element plus, let's just keep it to something good, and yes, so for the last element it will be pointing to null. Okay, so let's just copy to that, and it will print here null. So that is for the last element, just for like representation purpose. You do not have to write these things, and this arrow also, and head equals to head dot next. What I have done here exactly is print linked list as a function that will take up parameter of the head node, and I have created a while loop and head is not equal to null. So I have printed the element and the arrow. When head dot next equals to null, then it will print null also. And let's just change the line, and I have implemented the pointer by next. So let's just run that program easily and check what it becomes. So yep, 1 2 3 4 and null. So we have basically created a single linked list, and that's all linked list all about. um, let's just also add um, yep, single linked list. Or yeah, this is the major class that will contains all the links, singly all the references to the classes. You can dive in straight to the here, and it will automatically tells which class to go for singly linked list. It will contain singly linked list, what I can say, representation. Okay, no problem. Let's say what it says. So yep, I think where are my notes? So insertion, and I think this is basically the insertion here. How are we inserting? Okay, so this is the insertion in the linked list, and the next is deletion. So let's just code whether we should code this on in this file only, or shall I make the next. mm, let's keep it to another file, because when too much code into goes into one file, it become generally a problem for the beginners, and that's what was I was facing last year. So yes, let's keep it to a new file. No matter I have to write another code also, same code, linked list deletion. So yes, okay, now let's just also, I will be adding the link to the video here which I will be referencing to. Okay, that would be a later part. Let's just simply copy that for the saving of time. And okay, okay, what it is saying, cancel, and just keep it to node, and just also keep it to node. So it is all about the deletion and what exactly deletion means in the linked list. So let's just explain. um, Now let's say we have a linked list 1, okay, 2, 3 and 4. Now we have like in the node section we have deleting a given key, deleting a given position, and deletion of the linked list. So deletion, yeah, just a second, I should be a little less. So what I will be discussing is deletion of a linked list, deletion of a given key, and deletion of a specific position. So yes, this is all about the linked list. So now that is the head pointer here. And now if we want to delete the linked list, for this case we do not have to do anything in the JVM to delete every instance, just do head equals to null. So garbage collector does the work here. Okay, so the first case is solved easily. You just keep the head equals to null and there will be no references to the instance of the linked list, and all the memories will be automatically collected by the garbage collector. So yep, it was very easy one. Now for the second case, deletion of a given key. So for this I think it's a very basic problem. If you have like it's a very basic problem, you do not need to think of anything, just you make a for loop, traverse the linked list, and if the key is found, let's say it is 2, then merge this pointer, the previous next pointer, to the deletion next pointer. Let me explain it once more. And this is the previous key, so the previous next pointer should point to the deletion, like the current next pointer. So the actual linked list will be 134. Okay, so that is our second test case. I think that makes sense. And now for the deletion of a specific position, so like we programmers generally count the position from 0, and if the integer that is represents the position is like from 1 or 2, you do not have to care actually in linked list. It's all about what you start counting from. So just keep or you can also like keep the check for the corner case also, like there can be a case where a given key does not where a given key does not exist in the linked list. So you have to just first check it also that the given key whether exists in the linked list or not, else your test cases will fail. So the next is deletion of a specific position. So for the position you just have to go to the specific for loop and increase the counter, and when the counter equals to position, and then you have to do the same thing as you have done in the given key. Counter equals to position. Now you have to do the same thing as you have did in the problem number 2. So this is our solution. If counter equals to position to the second part. So I think that is all about the linked list in this and the length of the linked list. So yes, these problems are all about the for loop, and there is nothing such to be as done in this, but I will code it actually. For the length of the linked list, you just have to iterate through the whole linked list and just keep a track of the counter and do it. You can also iterate it recursively or just do it whatever you like. So yep, let's move on to the linked list deletion, and let's just copy the whole code here. I think I would be needing the whole code, but no problem, I have just made the another file, and while I have to singly linked list, and I have to remove all the sorts of linked list, and where I can do that, yes, there is no option of match and replace. So singly linked list. Uh, okay. So Yes, we are back to the singly linked list part, and now what we have to do here is that deletion of the linked list. Oh, I'm sorry. Where we have gone. Why? No, I'm sorry. Okay, we are back to somehow, but I'm not able to see actually where the text has been gone. Okay. Think we are lost in the space. I'm not actually able to identify where our linked list section has gone. So I um, I'm not able to find it exactly. No problem. I think I had made it clear. I'm sorry, guys. I cannot get back to the board, but yes, let's just dive straight into the code. So the next is deletion of the linked list, and I have my notes here. So deletion, if you want to delete a linked list, deletion of the whole linked list, then do head equals to null, nothing else. Now for the deletion of a specific key, call the specific function delete key and just pass a key to. Now I will make a function private void delete key, and that has to be static because the call has to be made from the static function, and it will take an integer a. Okay, so let's keep that to element. Okay, element equals to the key to be deleted. Now what I have to take here is that another node pointer of head. So okay, now while okay, I have to do one more thing, is that keep a track of temp pointer which will point easily to null. And now while what I have to do here exactly is I have to keep track like the temp pointer, and if the temp dot next element. Okay, so let's just not use another what I say, that let's just not use another node temporary. Let me just think. Let's say this is head, and we have to keep the track of the head pointer also. So I have created a head pointer, and let what I think is that if I have point the reference here, let's do it first. We can only know what has to be done next. So if temp dot element equals to element, then uh, temp dot let's say next dot element. Okay, so oops, let's just temp dot element equals to null element. Now what we have to do exactly, let me first write the brute force approach. So previous equals to head and temp equals to head, and okay, previous is head, and temp dot element. Okay, mother just stuck. So head is this, and this is also temp. So that is exactly where you are stuck. So you do not have to stuck majorly. I'm just thinking a better approach for the solution. I'm not stuck. Let's just not do that bullshit and just keep a track of the pointer head, and while head is not equal to null. Now what I have to do here is that um, if head dot element equals to element, then temp is the previous pointer, temp dot next equals to head dot next. Okay, and temp, okay, head equals to head dot next. So like what I have to do here is that head would keep moving, like, okay, but in that what case also for the first look in just a second guys. No, temp equals to head, and like temp is head equals to what we have to do here while head is not equal to null. Now if temp should like is pointing to head and head dot next. Okay, so deletion of a key. Why I'm doing this? Okay, so I'm keeping a track of previous pointer here. Previous would be head, and head equals to head not next. Okay, if head is not equal to null, then head dot element equals to element, then you have to just do previous dot next equals to head dot next. Okay, and previous equals to previous dot next, and head equals to head dot next. I think I have deleted that key, but you think here okay, now previous is equals to head and head is equals to head dot next. That means the temp pointer is previous pointer and head has gone to here. So what I did wrong here is that I have skipped the first element comparison as you have used it. So you have to also compare if previous dot element equals to element, then what you have to do here is that like that means the first element as the matching element, you have to delete that. Then what you have to do is head equals to head dot next and return. Okay, okay, then what you have to do here is that you just have to print the linked list, print linked list head, and then print linked list head. Now let's see what we can do. Okay, so we are going to delete the second element, and nothing has been printed. I think, what is this? It is always null. Okay, okay, so yes, and that is another major problem here, that we have not uh, while because head is gone to null, you have to just keep the track of one extra node temp which will also point to it. So basically you have to just keep printing temp. Okay, now just do that. Okay, so I think I have deleted that. That was not like that was an easy one, but you have to just go with the corner cases. So the next problem is deletion of a given position. Now position anti-element anti-position. Now you have to check whether the position lies or not. So and you have to keep the track of head pointer also. So deletion at a given position is like deleting of the same key. And okay, so what we have to do here is that okay, so while head, okay, so head is not equal to null, but that change the pointer. Okay, node head, node temp equals to head, and let's just uh, count like position is like count equals to 1, and if count equals to position, then you just call delete key which contains head dot element and temp pointer, and you are basically done. You do not have to do anything, you just have to follow the same and count plus plus. So let's just delete at position. Now I have deleted the key. Now delete at position 1 and pass the node head. So just do that, like the linked list 3 4, and it is printing 2 times. Why? Okay, because you have not break it. You have to do some sort of shit. Okay, and it is running because head is not equal to null and head has not been moved to next. I'm sorry guys. Okay, so this will not happen again. Then so yes, this is the code for deleting at position, and I was literally not stuck at this, but yes, I was involved in some thinking to like do not use 2 pointers here, but I will like I'm thinking the solution whether we can like reduce this um, extra pointer or not, but let me just think one more time that whether we can do this without this or not. So no problem, just we can move on to the next problem easily. And okay, so yes, we can, I think we have to keep the temp and the previous pointer. I think yep, you have to, you cannot bypass that, because that is the main, you have to just keep the previous reference and the temporary reference to keep the head storage. You just have to, I was basically confusing myself to remove that. I think with more much of problem solving we can get to a solution where we do not need more type of memory spaces and we can optimize more. But yes, I am also learning these days, and um, I was not knowing about that. So yes, that is all about the linked list deletion class. And what is the next to do is length of the linked list. So like just do it once again. So like for the length of the linked list, you do not have to do anything, just print length or length linked list, and you have to just point the head, and while head is not equal to null, and you have to just keep a point count equals to 0 and count plus plus and head equals to head dot next. So that is basically all about uh, the solution, and that takes n complexity, where n is the length of the linked list. Let's check out the complexity of the another print linked list. N complexity. Okay, I'm sorry. and I will be writing the complexities of the programs also. And delete key is like a delete key, so basically it will take maximum of O(n) complexity. Let's because uh, you can the user can have like user can request the key to be deleted, which is to be the last key of the linked list. So that is also O(n) complexity. Okay, so guys, I think and that is most for the video one that I will be covering, and this is done majorly. So I think I have explained most of the part of the linked list, and there is nothing to be um, like to be fair about linked lists no more. I think for the beginners I have solved most of the problem, and uh, I think it is the most uh, explained and detailed solution to you for the linked list, as I have created the linked list in front of your eyes with the code, and you can see like I have explained at each step what linked list exactly is. And I think the internet does not have these resources at this time, like in which you are guided along line by line. If you are if you are going for the free courses, then I think it does not have such things these days. But if I'm able to provide that, I think that is good. So I have not run this program also. Okay, that is printing nil because you have printed hit. Actually, I think it's my sleep time. Um, so yes, 4. Okay, guys. So and that's all about the video. And thank you, guys. Thank you for watching. Keep subscribing and keep sharing, guys, because I have received a lot of feedbacks from you guys, and most of the people are getting getting too much help from these videos, that I think. And there are too many people who are watching this which are also not known to me. So guys, do share that video, and thank you, and do drop your comments and feedbacks. Thank you. Bye bye.